Hi, welcome to our math. Today I'm doing a series of videos on higher order polynomials. This says find all the zeros of the following polynomial. Don't forget some can be complex. And you're given a zero, 3i. But if 3i is a zero, so is positive 3i because complex solutions come in complex conjugates, the positive and the negative. I want to remind you that I is equal to the square root of -1 and I squared is equal to -1, which is going to be important very soon. Okay, so I'm going to use synthetic division to divide out our complex zeros. I think doing synthetic division with complex zeros is kind of fun and bizarre and weird. It takes a little bit of extra work, and I'm going to start with the positive. I like the positive better. So let's see the coefficients, and you need to leave a little bit of extra space. So 2x to the fourth minus 3x cubed, at least for this first one, 13x squared minus 27x and minus 45. Add down and then multiply. 2 times 3 is 6i, and then this is -3 plus 6i. I see why we need the space. I'm going to multiply these, and I'm going to do this I'm going to actually multiply this out. So 3i times -3 plus 6i. Let's see, -9i plus 18i squared. Now, I want to remind you once again that I squared is a -1, so this is really going to be -9i minus 18. When I add down, I'm going to have -9i minus 5. Okay, so now I need to multiply that by 3i. 3i times -9i minus 5. This becomes -27i squared minus 15i. Again, I squared is -1, so this is going to become a positive 27 plus 15i. These are going to cancel when I add down, and I'm just going to have that 5i. When these multiply together, 3i times 5i, I'm going to get 15i. This is a 15. I'm going to get 45i squared. I squared is -1. This is a -15. Minus 15i, minus 15i, minus 15i, minus 45i. This is going to become a positive 45 because -45 times -1 is a positive 45, which makes that a 0. There we go. All right. So when we factor out the -3i, it is a lot simpler. We're going to use these coefficients. You're like, how is that easier? Trust me. -3 plus 6i, -9i minus 18, and where am I looking? -9i minus 5, and -15i. Okay. Add down, multiply. I'm going to get a -6i. Those are going to cancel, leaving me with -3. These are going to multiply, 9i. These are canceling, leaving me with -5. These will multiply, 15i, 0. Right? Isn't that beautiful? I love how that all works out. So then we have 2x squared minus 3x minus 5. All of the imaginary bits have gone away. All of the complex parts. We are left with a trinomial we can factor. I'm going to factor it with AC. So 2 times -5 is -10, and two numbers that add up, multiply to -10 and add up to -3. It is not 1 and -10. However, 2 and -5 work. Okay. So we have 2x squared plus 2x minus 5x minus 5 equals 0. When I pull out a 2, I'm going to pull a 2x out of the first two and a minus 5 out of the second. I have 2x, x plus 1, a minus 5, x plus 1. X plus 1 times 2x minus 5 equals 0. The thing is, when two numbers multiply to 0, one of them has to be 0. So either x plus 1 is 0 when x is a negative 1, or 2x minus 5 is 0 when 2x is 5, or x is a 5 halves. So I'm going to come over here where I have more space. My zeros are the 3i and the negative 3i. And then the negative 1 and the 5 halves. This is what the video is asking us to find. We could take it one step further for extra credit, and we could write this as a product of the factors. We could say, if we wanted, f of x equals x minus 3i, x plus 3i, and then bring these two over. X plus 1, 2x minus 5. So this is really what's being asked. All right, I hope you've enjoyed this video. Please subscribe to my YouTube channel, and I'll see you on the next video. Thanks.